I'm really excited about some of this physics I'm writing because it's giving that owner's manual to unification type of thing. You know, it's like we got here, but we forgot the manual on the way down. So,
Yeah,
you know,
that's what Bucky always said.
yeah. So the owner's manual is useful, when operating the universe as we are. Seaspiracy on Netflix. And it's about the state of the oceans, how tied is our existence to the state of the ocean. And, you know, the short term gain that's going on that is definitely affecting the sustainability of the ocean. And as a result of the whole planet, which definitely to the survivals of mammal on the planet on dry land, and so realize that things are connected in ways that are not so obvious. So, one of the things I'm doing right now is writing equations about collective behaviors, and it's so fun. I'll give you an example. Like if you put a bunch of, and people can look at videos of this on YouTube. If I think if they search metronome, synchronized metronome, it'll come up. And so you can think of like 100 metronome that you start at different times in random ways. And if they're on a table, they're gonna stay random, assuming that they keep, a constant velocity, and they're gonna not synchronize unless you put them on a table that's able to move. So if you put the 100 metronomes on something on wheels or something that's suspended from the ceiling, like a big table that's suspended by the ceiling, and so it can move, then that couples to the movement of the metronomes that are going on the table. And eventually, fairly rapidly, they all synchronize and they all start ticking together. No matter how random you start them, they're all gonna synchronize and they're all gonna produce a collective behavior, right? That has a larger energetic effect that's coupled to that table. So now you introduce the concept of coupling, right? So there's a coupling. In this case, you could think of a coupling in momentum, right? That's energetic transfer of the metronome to the table that's able to move, and then the table back to the metronome that makes it synchronize all together, right? For a maximum amount of energy. And so this is where if they were random, then the energy cancels out in all kinds of ways, and the table wouldn't be moving. There's as well like examples of this as well in terms of, and these are physical theories that have been written by other scientists that I'm utilizing in the physics I'm writing. The coupling of, for instance, fireflies, right? So fireflies all blink. Well, yeah, you would think they would blink in a random fashion. That their blinking would be at all kinds of time because it's, biochemical photonic emission that's occurring in one bug, and there's no reason that it would be correlated to any other bug. Well, it's been found that if the bugs are close enough together, they start blinking together. And so you got to wonder what's making them synchronize. You don't need all of them to synchronize to know when each one's going to light up. You just need two adjacent one to sync,
Huh.
right?
Huh.
To couple, and then the collective behavior of all that makes it all sync. So the idea is that you get this could be thought of as a time coupling, for instance. So you
Mm-hmm.
can think of momentum coupling, time coupling. You can think of electromagnetic coupling, and this is some of the physics we're writing right now, which
Mm.
describe the electromagnetic coupling of scales. So think of the metronomes again. So it's,
Wow.
you can think of the individual behavior coupled to the table, right? Which is the larger scale that it's coupling to, right? And
Mm.
and then when the energy of the table goes back into the metronome, right? That's the coupling downscale, right? So
Mm.
then you can think of the coupling relationships of the scales
Wow.
in terms of individual behaviors, like a Planck plasma, for instance, of all the little Planck's oscillators, and then their collective behavior, right, which is the coupling to the larger scale. So, like how they all spinning in the same system that we call a proton, and then that again and again and again. And when you so for the electron and so on, and and when you do that, you get really fundamental equations for quantum
Mm.
theory and relativity present just in the rendering of these equations for only the proton and the electron. That is, you output all the classical physics and quantum mechanics from
Mm.
just the coupling relationship of a proton to an electron. Not just in terms of their electromagnetic coupling, I mean that in terms of their gravitational coupling, their mass coupling, and so on. And so it's not just one force expressed, it's all the forces, like the strong
Mm.
force, the weak force, everything is expressed
All coupling.
in this
Mm.
coupling of electromagnetic information transfer that's occurring between two systems, um in a and which result in the universal coupling of all systems, right? Meaning that
Yeah.
there is that's the two fireflies you can
Right.
start with, right?
Yeah.
And then you output the scales, and then you just scale, and
Mm.
you get the right answers. For instance, for the size of the universe, its temperature, its mass, all this stuff comes out.
Wow. Wow.
Or you get the right answer for protons, electrons, muons, all baryons, and their charge and their electromagnetic field and their angular momentum and all this stuff. So, and
Mm.
temperature, stars, galaxies. So now you have something where you are writing the physics for the local observation of what you're experiencing. However, those physics are scaled to what is non-local to you, because the physics stays the same, the mechanics just scales. So you have local and non-local physics. So you eliminate the problem of it's Mach's principle, but basically the frame of reference is the closed system you're observing in the context of the larger system. So it's
Mm.
coupled, right? The
Mm-hmm.
metronome and the table, and then
Yeah.
the table that table is on, and the table that
Mm-hmm.
table is on.
Mm.
So
The
you can
turtles.
imagine that a small set of metronomes could move a very large table, right? It's the principles of resonance.
Yes.
Tesla was really fascinated with this. He almost destroyed the whole building
Hmm.
by just
Yeah.
resonating one of its I beams with a little tap, at the right frequency. So the coupling of these scales are very, uh, uh, like you can think of it as like the exchange between these scales in terms of their angular momentum or their energy or their time or whatever you want to consider. When you consider those things, the result as well is that you get all these fundamental constants. So for instance, you find the Rydberg constant at the atomic level, you find the gravitational constant at the classical level, you find you know uh, the Heisenberg uncertainty principle and Schrodinger's equation on the quantum level, and you find the Klein-Gordon equations, and so basically you can see that like all the things that are known in physics are unified, and you can find this unification all the way down to um, special relativity, general relativity. So that
Hmm.
means you can describe the energetics of the system very
Hmm.
precisely, right? For instance,
At
with
all
special
scales.
relativity, this definition of special relativity completes special relativity so that now it has a deeper physical meaning. And the
Hmm.
reason is because now there's mechanics attached to the concept of mass or the energy that we call mass. That is, it's not in the sum, an assumed quantity all of a sudden in these equations. It's something that is coming from a very specific mechanical function.
Mm.
And that
Uh-huh.
function outputs quantum mechanical equations. So it unifies,
It
relativity
unifies.
with quantum mechanics in a very fundamental way. It's extraordinary to witness it. It's beautiful.
Yeah.
It's hard to describe how deeply it's affecting my awareness.
I can
Um,
understand. I can feel it as you describe it because it's there's a simplicity within that function or that model that you just described that you could see just fractally permeates all scales, and that simplicity is what is unifying it. And it sounds to me, Nassim, like when you describe the metronomes, and if they're on a rigid table, they don't sync up. But when the table is able to move, it sounds to me like that's the feedback feed forward mechanism that is providing the relationship that allows for the synchronization and resonance to occur.
exactly.
Without that feedback, without it being possible to provide that feedback, it doesn't happen. So this
That's
is
right.
obviously occurring at all scales, this relationship of interaction that is moving everything simultaneously, you could say.
Well, yeah, and it's that the feedback here is a very physical one, meaning
Yeah.
you can assign very fundamental, very straightforward mechanical equation, for instance, to transfer of momentum or energy or electromagnetic
Mm-hmm.
coupling or
Sure. So many.
it's very physical.
Mm-hmm.
So it's not like some concept of feedback in when we're talking about information feedback,
Mm-hmm.
it's not like a philosophical thought, although it is
Right.
that
Yeah.
too.
Exactly.
It has very
Yeah.
physical meaning, meaning the transfer of
Yes.
energy is
Yes.
done in a very physical way, right? In this case, is spin, networks, right? Angular momentum
Right.
and time relationship,
Yes.
right? Time
It
comes
reminds me of
as a frequency, right? So if it has a
yeah,
frequency
cycling. Yeah.
per second, right? Time,
Yeah.
right?
Yeah. We have time.
Yeah. So
Exactly.
not time in an esoteric way neither. I'm talking about like physical time.
Yeah.
Well, physical
Physical,
sense
functional
that an
time.
angular momentum is giving a tick.